Welcome to Ask and Learn.
Hello and welcome. We are looking at Chapter 5, Section 4, Problem 16. We're asked to prove our answer in Exercise 8. So let me pull that up real quick. So that's finding the sum of the first n positive integers. So prove Exercise 8 correct. So we want to use induction to prove this correct. Okay, so I have it pulled up here. Just looking back at exercise 8. So induction, the first step of induction is we want to prove the base case. So the base case would be that sum of the first positive integer is 1. And so sum of 1 equals 1. If you look, if n equals 1, return 1. So that's basically our first step of induction there. Sum of 1 equals 1. And if you look at the, maybe I should write it off to the side here. So we'll say procedure, sum n's a positive integer. If n equals 1, yeah, this will make it easier to talk about. Then 1, else sum n minus 1 plus n. So first step, sum of 1 equals 1. So that's the exact first step here. All right, so for step 2, we want to prove that if we know that sum of n equals 1 plus so on up to n, we want to prove this whole statement true. Then the sum of n plus 1 equals 1 plus all the way up to n plus 1. All right, so this is what we want to prove. So this isn't really part of the proof. It's just this is what I'm going to prove. So I'm allowed to take this part for granted. This part is what I'm arguing from. This part is what I'm arguing to. So if the sum of n equals 1 plus everything in between from 1 to n, then I could say that, let's see. So, so there's different ways you could probably go about doing this, and you might even use a slightly different inductive step here. But what I'm going to do is I'm going to add n plus 1 to both sides. It's an equation, so of course I can do that. So with this, now I'm going to use, I'm basically going to use my procedure to show that this right-hand side and this left-hand side, one of them is going to give me sum of n plus 1. So so the right-hand side so if we start with sum of n plus 1, and use our procedure. Um, Obviously, we're assuming kind of that n is greater than 1. So this would equal, using our procedure, the sum of n plus n plus 1. All right, so the way we set this up in the beginning, you could have done it differently, but we kind of have to lean on this fact here. Sum of n plus 1 equals sum of n plus n plus 1. So maybe I should put some text in here just to make it more of a narrative. So we know this is true. So notice that this right here is the same as this right here. So, oops, I don't want to use green there. So substituting the left-hand side, and I'm talking about this left-hand side here, gives the sum of n plus 1 equals 1 plus everything up to n plus n plus 1. And that is actually what we wanted to prove. So we started with this true fact, and we used mathematical steps to get to this and prove that it's now a true fact. So we can say as wanted, and so this proof is done.